Thank you.
All right, guys, we're gonna get started. It is a pleasure to introduce Mariela Fernandez Campos today. So Mariela is speaking in honor of her award last year in the fall 2023 of the Chunhua Zhang Legacy Travel Award. So Chunhua was a member of our department. For those of you that don't know, she was a faculty member who passed away unexpectedly at the age of 44 in 2021. And so to honor her dedication to graduate students and her mentoring abilities, we give this award every year. Last year, Mariela was out of town and so wasn't able to give her presentation, which is part of what you get to do when you win this award. It's $1,000 to go travel to a conference and to give this great presentation. She is giving it today. She will do a great job. Mariela grew up in Costa Rica, and she went to Zamorano School, Agricultural School in Honduras, and graduated in December of 2016. And then she eventually, after a couple of years, made her way to Purdue in the Cruz Lab, and she got her master's degree in epidemiology of wheat blast disease in 2020. And then continued on to get her PhD. Well, she's still getting her PhD in the Cruz Lab, but she'll be graduating soon. Mariela has done a really beautiful job of combining remote sensing and machine learning with disease modeling to predict plant diseases. And she's going to tell you about her work today. She's also an awesome team player. She's a major force in our grad student organization. You've probably seen her around, and she's organized a number of different student conferences, like Corteva Plant Science Symposium. Some Zamorano students have helped bring them in. So with that, she's going to tell us a little bit or a lot about her research and also a little bit about her personal journey. And so let's welcome Mariela.
First of all, I want to say thank you so much for being here, and I'm super excited to present a little bit about the journey that I have been spending here in this university, and I'm honored to receive this award. So thanks to the Department of Botany and Pathology and the grad student organization. So I'm from Costa Rica, and as Dr. Angeli said, I went to Zamorano University, and I see that here are a lot of Zamoranos, so thank you so much for the support. And after that, I was blessed with an opportunity, a really big opportunity that changed my life, that is to do an internship here in Indianapolis in Corteva. I was working with the biological characteristics research team, and I was trying to characterize what are the new fungicides, insecticides, and herbicides that we will see in the market in the next 3 years. So I was pretty lucky for that, and I was, let me put the time so, because if not, just want to control. Perfect. Yeah, so one of my mentors, Fernandez, told me to go to the APS because I told her, like, I want to go and get my master's. I knew that I wanted to go to get my master's. So that's when I connected with Dr. Cruz, and he was starting as an assistant professor, and he invited me as a visiting scholar. And in 2020, during COVID, I graduated, and I was working in epidemiology for wheat blast. And after that, I started in 2021 my PhD journey and consulted. So today, I'm gonna talk a little bit more about what type of research I have been doing in botany and plant pathology. So the title of my presentation is Advances in Modeling Wheat Blast and Corn Diseases. So let's dive in. First, I just want to say that my presentation is divided in 4 different objectives. So one of it is just an overview and introduction about plant disease epidemiology and some other concepts. And later, I will talk about wheat blast modeling, corn disease modeling, and at the end, I want to give a little bit of some, like, not advice exactly, but I just want to share some of the resources that we have here in Purdue. Okay, so what is plant disease epidemiology? So the first thing that we think about epidemiology, I'm sure that this has been a word that is, well, that has been really famous since COVID, right? That the majority of the people know, and we know that epidemiology is the study of the changes in disease intensity over time and space. So normally what we do is we use disease modeling in order to understand these diseases. And for that, we use information of the host, the pathogen, the interactions, and also the interactions with the environment. So, but why it is important? Why is important epidemiology? Why is important to understand about the epidemiology of the diseases? So it is important because we know that diseases can, in optimal condition, it can create yield reductions as well. It will decrease the quality of the food, and expenses will be incremented as well. So in order to study epidemiology, one of the basic things that we do, one of the basic concepts that we use is disease severity. That is one of our sources. So disease severity is the degree to which a specimen is diseased. So it can be a plant, a part of the plant, or a plot. So normally when we talk about plant disease severity, we can see it like from two different perspectives. One of it is the estimation. So that is using our eyes, that is the sensor, our eyes. Sometimes it's subjective, we know, like it's labor intensive as well as time consuming. And we also have a disease measurements for plant disease severity. So there are like more objectives, high throughput, and it can be more efficient. So today I will be talking about doing modeling using visual and as well RGB images, and also the multispectral images. Okay, perfect. Another data source that we use for modeling purposes is weather information. So we know that weather is key in order for the disease to develop. So we have that information. So now let's dive into the diseases. So wheat blast is a causal, the causal agent of wheat blast is Magna porta triticum, and it is a fungal disease. It is not here in the United States, but has been detected in Africa and also in Asia. But it is native from South America. And the most important thing is that wheat blast can cause yield losses up to 100% in less than 2 weeks since the detection. So this is threatening, this can threaten the food security. So here is the disease triangle. We know that temperature and relative humidity and free water is essential for the disease to develop. So here we can see some of the symptoms. So don't think that these spikes are mature. So as you can see, the bottom, the stem, they are green. So it is maturity. It's not maturity what is happening here. What is happening is that the disease arrived and it's just bleached, these spikes. But also this pathogen can also create leaf lesions, as you can see. And one of the most important things is that it can shrivel the brain, and also the weight will decrease. So the other disease, now going to corn diseases. So we have Gloxinia purissora, what is the causal agent of southern rust of corn. And this disease normally produce a small orange pustules that normally you will see them closer, and you will see them like in the upper leaf surface. It is a risk for the corn here in Indiana, and it has been reported more than 45-year yield losses. Here you can see the disease triangle. And what you can see is that southern rust likes warm temperatures. So here are some of the symptoms. So the leaves can be infected as well as stems, and it will premature the corn. The other disease is star spot of corn. So I know that there are a lot of people here that are working in star spot from different fronts. So we know that this disease is endemic from Mexico and has been distributed in the Americas, and in 2015 was reported here in the United States, was first detected, and since then we have been working, and since then it has been like an issue, because it can cause more than 25 to 50% yield losses. So one of the signs or that we can observe from this disease is the stroma. So if that stroma will carry sexual and asexual spores. And we're still learning a little bit more about the epidemiology and what are the best conditions for the disease to do. So here you can see that dark spot can affect leaves and as well the husks. And it will produce some fluorosis and necrosis. And these are the fish eye symptoms. That's how we call it normally for diseases. So now that we know, we have an overview of the diseases that I'm going to talk about today. So let's dive into wheat blast modeling. So for this wheat blast modeling, the objective was to generate a wheat spike blast image library. The second was to analyze the agreement of those diseases, of those images that of the disease, the images that we will be using for training the models. And we test the agreement of two plant pathologies, and we also measure the disease with image software. And we also develop an accurate model that is a deep convolutional neural network model that can detect and classify the disease severity in different categories. So these experiments were carried on in Santa Cruz, Bolivia, where we had six cultivars, and we inoculated the spikes when they were fully emerged. Later, we incubated, and since then, we started taking images and also assessing the disease severity. So at the end, we ended up with a total of 2,000 images around. And so what we did in order to train the model, we divided in 3 different categories. So you can see the category number 1 is no symptoms, the category number 2, low levels of disease, and the category number 3 is intermediate to high levels of disease. And that decision was based on the literature. So in order to train the models, we needed to prepare the data. So what we did was divided into training and testing sets. And as well, this you can see the distribution. We had to use a data augmentation technique here for the category number 2 and 3. That is a common technique for modeling. And we test the reliability of the analysis. So what is reliability analysis? So what we want to understand is if there is consistency on the evaluation of one person and the evaluation of another person. So we want to know what is the agreement of that between a specific specimen. So for that, we had 2 pathologies that we estimated the disease severity, and later we also use image J to measure what is the disease severity of it. So, and the most important thing of this is that we're using data to train this model. So if we don't have good data, we're going to have a bad model. So in order to do that, what we found was that the Cohen-Kappa coefficient is going to tell us that agreement, right? And what we found was that there was substantial agreement between the raters and image J. So that gave us like the green light, and that tell us like, okay, let's move on with the model training. So normally the deep convolutional neural network models, the CNN, normally have 3 different layers. So one of it is the input layer, the hidden layers, and the output layers. So I want to mention that this part of the modeling, I was collaborating with Dr. Jahan Shahi and also with Yutin Kwan from civil engineering. So we use a pre-trained model, and normally what we do is if we have the data, we put it into the input, and later these different neurons and different connections is going to try to learn about what are the features from the images, and also will classify the images in the different categories. So that is the theory behind it. So after that, what we did, with the testing set that we reserved that the model has never seen before, we use those images and in order to feed it, we feed those images to the model, and it was able to classify the images. So at the end, what we found was that I just want to see right now because of time. I think that I will focus only on the F1 metrics. So this metrics is like an overall between precision and also recall of the model when classifying images. So as you can see here, we can see that the model by itself was pretty good classifying the images of the category 1, as well the category 3, and the category 2. He was struggling. He struggled a little bit, but we have a 0.88. So that what that means is that from 10 images that will feed, you will have 8 that are good. So or 8 or 9 if you want to round up. Yeah. So we have those results, and in summary for this part, we generated with the Spyglass image library, and as well we developed the deep convolutional neural network model that was able to classify the images under control environments. Okay. Water. Okay, so now let's dive into the chronic disease model. So for this research, that was the weather-based simulation using weather-based simulation of southern rust of corn, we had a question. So this research question was, can we integrate visual assessments and weather information to better understand the southern rust progression of the disease? So this is an experiment. So with Brendan, where are you? Okay, there you are. So with Brendan, we team up, and that's how we are able like to go to different fields. We have one, normally we go to Southwest-Back, to feedback and feedback. So we collect the same data, but we have different approaches. So at the beginning, I was starting researching southern rust, but later, because of some other reasons, I move on to southern rust. So, but we have like different research questions. Yes, so we established this experiment in Southwest-Back, where we have like a strip plot design, and the strip plot, and what we have here, we have 3 different treatments. That was the non-treated control. We have some strips that we apply one fungicide application, and the other one where we apply 2 fungicide applications. So today, for today's talk, I will talk about the non-treated control for the modeling that we use was for that data in specific. So what we normally do in our field trials is we divide it in grids, the entire field. So the way that we do it, we assess the severity visually of, we estimate severity, the visual estimation. Yeah, we do visual estimation of southern rust, and we, in this case, in this time, we collected information of 6 plants and of the yearly in this month. And we also have a weather station that was on-site weather station that it has more than 60 weather variables. So we calculated the daily mean of each variable in order to use it for our model. So we know that simulation models are used to predict the course of epidemics. So the first thing to do that, to do this simulation model, was first to use population growth models. So this population growth model is gonna help us to estimate a value of disease for each day. Because normally when we go to the field, this time we went to the field 8 times, and it helped us to plot how is the disease progression over time. So we tested logistics. We needed to test if it is logistic, exponential, monomolecular, or bumpers. And also we have the weather variables, the daily weather variables. And later we have the modeling approach was multiple regression. using forward selection. So that is the pipeline, how we do the modeling. So some of the results that we got, so as you can see, the disease reached up to 30% in the non-treated control. And it is noticeable that we had an effect of the fungicide, where it decreases the severity. And the other thing that I wanted to say is that, yeah, we went to the field 8 times, but at the end, there were only 3 times that that's when we saw the disease, right? So sometimes you don't know, you just, yeah, so you spend like a lot of resources on that, but you're like looking for it. So, whenever I tested like the logistic, the exponential, the Gompers model, and also the monomolecular, the model that best fit the disease was the logistic model. So from that logistic model, what we obtained are some parameters. So these is the speed of the disease. So how much the disease will increase in every day. So we use that for our modeling approaches. And at the end, what we used was the logistic regression and the weather information. And later, we use that to fit the multiple regression. So here we started like to have a little bit of more involvement in fusion of diseases with weather information. Okay, so later here, what I have here is these results, that is the simulation model. It is actually like a simple equation, as you can see it. So what we have to do is we want to use this for later on. Like this is only one year of data, so I don't. That's something that I want to highlight. It's just 1 year of data, but that helped me like to start learning a little bit about modeling, and yeah, the resources of the grant that we had, like the program didn't continue, so that's why we only have one year of information. But I thought that we worked a lot, so it was we deserve it, like to show. So so yeah, so what we have here is like this equation, and what we have to do is like just substitute the values of that. That is the disease, the days after planting. So which day was the day that you want to simulate. So you just replace it with the values of the water content, the wetness level, the wind speed, and the air temperature in that specific moment. And as you can see, so here is the simulating. So in the x-axis, we have the days after planting, and in the y-axis, we have the severity in proportion, and the dots are the real disease estimations. This other one is the modeling. Yeah, the line is the modeling. And as you can see, yeah, there is some error, but it kind of like demonstrates how is the disease developed. So some of the limitation of this model, because it was only 1 year, so the model will not accept values that are lower or higher than the ones that it was trained. And we needed several years in order to say like, yeah, we have a model, right? And some of the next step is in this moment, we use only the mean of the disease, but also, yeah, we only use the mean of the disease, but also we wanted different descriptive or different variables, like feature engineering variables, like the cumulative, what is the interaction between leaf wetness and solar radiation or things like that. So, yes, and the next step can be like using data fusion techniques as well. So that takes me to this, the Tar Spot project that was exploring the potential use of weather and imagery data for Tar Spot disease modeling. And for that, we had 3 different objectives. So one of the objectives was to model the incidence using only one source of data. So it can be only weather information or only drone imagery, using logistic regression model and neural network. As well, the second objective was to use logistic regression and neural network model, but this time using the combination of both data sets. So, and the third one is to compare the performance of the modeling approaches. So for that, we started this project with the collaboration that we have with Dr. Telenko and her team, where we have where we have two different plots, two different experiments. And it was in 2021. That's something that I want to highlight because 2021 was a year that we have a lot of star spots. And the disease severity was assessed by Camila and Tifana as well. So there were like 6 times and 4 times. And in this moment, we were only focusing on the yearly as well for the modeling. Yes, for the modeling. Yeah, so now let's dive into the pipeline of how we're going to do this modeling approach. So this is also a collaboration with Dr. Jahan Shahilab and Abhishek, who is a PhD student in computer engineering and civil engineering in both. So here what we wanted, we started first with the disease and we had different categories, as you can see. So we wanted to estimate the disease at 1%, at 3%, and 5%. So later that we have those in those categories, we extracted the vegetation indices and we developed some feature engineering. So for example, as you can see here is the plot, and we extracted the value from it, and we also got the mean, the standard deviation, and other variables. We also have weather variables where in this time, we not only have like descripting like the mean, the minimum, and the maximum, but also some cumulative and also some interactions between leaf wetness, air temperature, and relative humidity, just to see like which one are gonna help us to understand more this disease. So at the end, we ended up like for the models that we were using, we were training with both data types. We had 142 variables. The one that was using only imagery data, in this case, the vegetation indices, was 52 and 90 weather variables. So that's were the initial variables that we have. And as well, we divided the data sets in testing and training set, and we use that information in order to train the logistic regression that it is a more linear relationship, and the neural networks, it will bring us non-linearity. So we just wanted to compare both of them, and the logistic regression is a traditional approach that has been in the literature as well. So what we did was to train the models, like to evaluate the disease, or to estimate the disease in 3 different categories. And here is just the results of 1 year. And I will tell you later where are the other years. But yeah, so we have here the comparison of the performance. And overall, what we saw was that models using vegetation indices and the neural networks was the one that performed the best for this data that we have. And in the case of the logistic, using the combination of weather and vegetation indices was the best option. And overall, we had that the neural network results were better than the logistic regression. And in conclusion, yeah, we realized that, well, we saw that the models using neural network predicted better the incidence of star spot, and that using multi-source data, it helped us to improve the performance for the logistic regression in this case. And yeah, some of the next step is to incorporate the information from 2022 and also validate the model performance for star spot from 2021, 2022, and 2023. That those are field scale research that we carry on with Brendan as well. In our team. So I'm not gonna continue talking about that because my exit seminar is gonna be November 18th. So if you're like more interested to learn about this type of research, yeah, so just come for my seminar. And also I'm gonna be presenting this poster as well in the symposium that we have in Botany and Pathology. So, okay, yeah, so the take-home message here is that we can use imagery data and weather data to help us understand the study of plant disease epidemiology. Okay, so, okay, what time do we have? 14, okay, okay, good. Okay, so, yeah, so, okay, great, yeah, so we have, I just wanted to share, so why I wanted to include here some resources for visiting scholars and for grad students. Because when I came here, yeah, I had some community with the Zamoranos, but there were many things that I had no idea that it would help me to make my life easier. So I was thinking like, why, like this is the perfect moment because many of us, we are required to be here. You know? So it's a great moment for me to share a little bit of the information that I have learned that we have here at Purdue. So the first thing that I want to say is that here at Purdue, we're really blessed and we're really, yeah, I'm really grateful in reality because it has helped me to grow in many aspects, not only in the personal level, but also in the professional level. And here are some of the resources that has helped me to be here. So one of the things is, let's see how many visiting scholars we have here. Can you raise your hand? Okay, good. Don't be shy.
Welcome.
Yeah, so I'm not sure if you knew about the place that is these courses that is from the Purdue Language and Cultural Exchange. So they have different courses to improve our English. It can be from reading, writing, speaking. There are some courses, there are short courses of it that we can implement our vocabulary as well. And I have two of those courses that has helped me to be here because yeah. So if you want to just take take your camera and look at that QR code. The other, that this is not only for visiting scholars, but also to PhD students and also faculty. So how many of you have heard about the Clifton strengths? Yeah, so the majority, you haven't heard about this. Good, that means that today I'm gonna introduce you to this. So this is a test that can help us to identify what are your strengths and also your weakness in the way, and they also will help you to provide some information about how you can improve your strengths. And this can be also seen like from a lab perspective. So the lab can take this and can identify what are those strengths that each individual person can have for a specific role, and that can help like to identify that. Yeah. And the other source that I have here is LinkedIn Learning. So everyone here that has a Purdue email, we are able to get into different courses that are in LinkedIn Learning by free. So it's free. Can you imagine, like, you can get a certificate by free, just putting your time, of course, and learning new skills. And we know that in LinkedIn, it's not only skills about project management, but also it can be about coding, modeling, or AI, you know, many other things. So yeah, you just need to go to One Purdue, and just type it in there, LinkedIn Learning. And another one that is amazing we're really lucky, and I have been told from different universities here in the US that we're really lucky to have the Purdue OWL, that is the Purdue Online Writing Lab. So they actually help us, they develop, I think that today Lisa sent an email about it, that they are developing they will have a course this semester for the first years and second year students about how to draft a proposal, how to improve the writing, and different things. And they not only do courses for the first and second year, but also the third and fourth years. So visiting scholars can also take advantage of this, because you can go there, just set a schedule, set a meeting, and they can review your resumes, and they actually can give you an interview, right? So the other thing is that we have the grad writing sessions that is from 9 to 11 a.m. and it's a great way to start your week. I really recommend it. I go, so if someone is interested, let's go. All right. So the other one is a speaking session, also to improve English. So they have it twice in the week. And what else? Oh, and the other one is that I'm also leading, no, it's not like a workshop, but it's like a grad writing session every Tuesday, every Wednesday before the seminar. So it's just 2 hours before the seminar. So you are more than welcome to come. And I just want to acknowledge everyone. I just want to thank all the collaborators, the funding agencies, my mentors, the Botany and Plant Pathology Business Office, and the superintendents at the 3 different stations that we have worked, as well my family, my friends, and many more. So I was not able to put everyone in this picture, but I also want to acknowledge the Costa Rican Student Association. So if you're starting your PhD, get involved. Like, it's good not only to do science, but also to do a little bit something that will distract you to it. So, and a way that you can improve your leadership is taking a lead role, like in our organization. So we have the Botany and Plant Pathology organization that they have different activities, and I also want to thank the Zamorano community here at Purdue. And yes, I'm all so if you have questions, I will be more than happy to answer. So let's see who's gonna be the bravest person here in the
I'll ask one. So you showed your southern rest coming in late. Do you know why that might be late coming in?
Yeah, so Southern Rust was coming late. So normally this rust disease this rust pathogen doesn't overwinter here. So that's one of the things. So every time normally, well, I don't think that there is like a theory that there is a paper where they said, but they said that the spores comes from Central America and also from Mexico all the way to here in different storms. And so that's how it comes. So it first needs to produce there, and some of the spores will go and travel, and it's a long travel, so maybe.
And then the follow-up is, do you think the model will look different if the spores come in July versus August?
Yeah, I think that yeah, it will look different. Maybe the exponential can be the model that will explain better that disease in that case if it comes. But that's why we have to do more research to have more information and to have a more robust model. Thank you, Paris.
Have you thought about using some of the kind of historically published weather data from the past few years? I think it's only like publicly available up to like 2022 with your equations especially for the southern rust as well.
Absolutely, we can do that. The thing is that we also need disease information, right? We also need to disease information in order to compare later on, but yeah, absolutely, we can, that's a really, really good aspect. We have to bring up.
Your really excited about what happened with your modeling apply for specific cases, like you developing into all the problems.
Okay, like if we can have a model that can not only model like weak diseases, but also core diseases, or
Right, remind me, your study only for monoclonal weak, right? This is for weak monoclonal or in your field.
monocropping, that's
Yeah.
what, oh yeah, so these different techniques, yeah, there has been research not only on this, but also in potato, and I also know that in strawberries, they have been using, and there are many other crops, and right now with the computer power and also that help us like to train models like not that easy, but easy, like in comparison to the past that everything needed to be like write it down or like in a small computer or like an old computer that it was, yeah, so yeah.
Yeah.
Tell me, yeah. Did I answer your question?
I just want to put your model could be applied for the interceding cases, like you grow two crops at the same time in the same field.
So do you think the microenvironment would change for the disease? If you had corn and soybean next to each other in the field versus a monoculture of corn? So that's the question he's asking. Do you think you could apply the model if you're changing, would the environment change if you had two different crops next to each other versus one crop on board?
Just only one. Okay, thank you for, thanks
Do you
for
think it would change? Do
clarifying.
you think it would change?
Yeah, I think that it will change.
So how would you have to go about doing that? Now we'll push questions out.
No, but it's good. Now I'm thinking of what she's gonna ask later on. No, yeah, I think that it will change because the microclimate, we know that, like if we have a tree next to our field, the microclimate of that specific place is gonna change. So one way that we can do, there are some cheap sensors, cheap sensors that actually we were working with Mark Sullivan, and that are these LoRa sensors that are like $50, something like that, so that you can install in the field, and you can install it like in different parts of the field in order to use it later on in the modelings and see not only like have one weather station, but also understand what is the variability of the microenvironment.
So if I'm a farmer and I'm just saying, this sounds very fancy, but is this predictive? Do you have good evidence that this is a better approach than me just scouting the field?
So first of all, I think that we need more years of information in order to say like, yeah, you can use this model. So I think that by this stage, if I use it right now in this moment, I think that the farmer can use it as a tool, but you also need to go and scout a little bit more, like just to identify if actually they see. But you need many years of data in order to have conclusion. It can be like more than 10 or 15 years in order to have the prediction model. So we know with the SCAP model, they have been researching for many years. So the accuracy is pretty good.
So you can go back retrospectively to all the data that's been accumulated and generate your model, but you can't necessarily do that with TarSpot. This just hasn't been around long enough.
Yeah, since 2015, this one. We're accumulating data.
I'm gonna give you an easy one. As you are an elder student getting ready to retire. To go off into the world, what would you give the younger graduate students coming up? That's piece of advice.
Yes. So the first thing that I will say is that, yeah, we are here and sometimes we are really busy. Everyone has many things, but it's good also like to interact with other grad students, to share like your struggles. Sometimes like, for example, I struggle in focusing and I was like telling Denise, like, Denise, I cannot do this, I cannot do this. So she started like to, I cannot read that many, like the paper like for long, because if not, my brain will get bored. So she told me like, well, use naturally. So this is an app that it will speak to you and you can go and read it. And there has been many resources. So I think that one of the things that we're here, everyone, we're learning. And yeah, try to touch base with different students like Anita. Yeah, and see others, like ask questions. The other thing that I want to say, that I will say, is also, yes, you have a main mentor, your PI, but also we have many good professors here at Purdue. So, and that many of them, the majority of them, they have the doors open. So you can just go knock up, like what I did with Dr. Miller, and say, like, can you show me how did you study for your prelim? I was like, okay, I have here this book. I have never been disorganized, but it was really good, you know. So the professors also were in our shoes. So just don't see it like it is something that is really impossible. I think that it's something that you just have to put the work in order to enter into grad school, to don't give up in the TOEFL test. Just do it. I did it 4 times, the TOEFL test, because of the reading section, just 1 point. And it was really hard for me. Like Dr. Cruz saw me crying about it, you know, because it was frustrating. So, but I'm here. I'm here. So if I'm here, like probably you also can be here as well. So yeah. Thank you.
Any more questions?
This class is on, is the disease still there or the disease is gone or?
No, so that disease is not here in the US. So it's not here in the US, but it is actually present in South America, and also was detected in Africa and also in Asia. In 2 continents, yeah, there. Yeah, but it's not here. But there is a jet. I was about to talk about that. Yeah, it's not here yet. But Dr. Cruz, during his PhD, he actually developed like a risk prediction model, and what he showed in that paper was that there are risks of, in the weak areas of production, there is risk that this disease can come and have an itch in our production.
And the next one is in the slide 34, you mentioned there are actually 16 variables for the weather data, right? 34. Yeah, so in the weather data you have 16 variables, right? But in this equation you only have like 4 or 5 variables.
Yeah.
So what happens with that?
So we use the stepwise forward selection technique that is a common technique that we use in regressions. Sorry, in multiple polynomial regression. So yeah, so what it does is the model starts using 1 variable, and later you will add 2 variables and test how much the prediction will improve, and then it will add another set, and at the end it will, with the different criteria, we can select what are the model that is predicting, what are those variables that are for prediction.
And in slide 32, here you have like 3 things, like T0, T1, T2. So when you have a field, so you were one part of the field you are doing only one treatment, the other part of the field you are doing two treatments, and that's how you measure the data, or?
So we do an average. So when we do the different reads, we get like, this estimation for that read, and later we,
So
yeah.
all the grids were treated, or all the grids were not treated, or some of the grids were treated, some of the grids not treated?
Okay, I know what. Okay, yeah, so as you can see here, like this strip had, the treatment number 1.
Okay,
This other one has the treatment 0.
okay.
Yeah, so the grids that you're saying, that we're looking here is the ones that we estimate, the grids that we visually estimate. We also have drone imagery of this information, but I didn't include it here, but yeah.
Thank you. I think one last doubt, I think doubt also. In the beginning, you started saying epidemic, but for one disease, you said it is endemic. Is there a difference for both of them?
Yes, so endemic, that means that it reproduces there, like it grew up there. It not grew up, but it show up there.
It is different from the epidemic and.
So epidemic, when we talk about epidemic, it is like just the increment of the disease in a population. So.
Thank you so much. The presentation was really very nice.
Thank you. I'm glad that you like that. Thank you so much.
You broke your
No te conocí cuando pasé. No te había visto.
Fine.